Good afternoon. I'm Pezo, and I'm going to talk about revolutionizing enterprise communication and then how to do Spring Kafka. So a little bit about me. I'm Pezo. Like I said, I'm a software engineer at Rabobank in total of 7 years. I'm at the tribe Insurance and Pensions in the team The Dark Side. We develop applications for insurances, so you can apply for insurance, and because we are at the back-end side, that's why we are called the dark side, basically. Now, a little bit introduction into Kafka, and then the event-driven architecture of Kafka. So in the past, when I was little, we did monolith applications where you have large applications with a lot of services and not a lot of teams worked on them. And you went, if you were lucky, once a month to production because everything has to work. And if something went wrong, you can say it works on my machine. Then we went to the microservices architecture where we loose coupled everything, but still with API calls with SOAP. We called those microservices, and in the end, you get a spaghetti environment. And then basically came the event-driven architecture, where the event broker is placed in the middle, and every service, which now is being called a consumer or a producer, can communicate with the event broker. And one of those enablers of event-driven architecture is Kafka. So how does Kafka look like? Kafka in a nutshell, basically. You have the Kafka cluster, which contains the zookeeper that manages your brokers. A broker has topics, and topics contain partitions where you put your messages on. To do so, you have Kafka producers, and to take messages from Kafka, you have Kafka consumers. So in service, your producer can send messages to a partition, and that is being loose coupled from your consumers, because your consumers can then start reading your messages independently. If some other service joins, he can start polling your messages on the partitions. So that is fine, but what happens when a broker goes down? And that's basically the big power of Kafka and the Kafka cluster. It is being replicated to your second broker, and you just can continue consuming, publishing messages to Kafka. So the thing is that all the messages that you consume or produce to Kafka are bytes, and the good thing is that's fast, but when you have to deserialize or serialize, if you don't have a good connection with the team that is producing, it can be a mismatch really soon. So then the schema registry comes in place, and this basically takes that away. You can define contracts between your producer side and your consumer side, and we do that basically in AVRO schema, but there are more, of course. Then there are also services that are streaming processes, so those are consumers and producers in ones. That makes it a little bit easier to consume and produce those messages. And of course, there are sync connectors. Those are no-code connectors. You don't have to code anything, but you just connect to Kafka, and what they are basically for are when you have, for example, a database that you have a source connector from one side, you have your MySQL database, and you have MySQL database on the other side. When something is placed on your source database, it will be transmitted to your sync database. That is it for that one. And then how does Rabobank use Kafka? And well, we use Axual. Axual is a company that provides Kafka as a service for us. So what we get is basically, they do the schema registration, they do the zookeepers, they do the brokers for us. We just connect with our services, and they also provide SaaS solutions for Axual, for the connectors via Axual. So it is pretty easy for us, and when you look at it, how we use it in the Rabobank, and how Axual basically was started. It started at the end of 2015 inside of Rabobank. It got developed by a team, and then it became a big success, and they became an own entity as Axual. And a couple of years later, now we use more than 1,000 topics provided in Axual, and we have around 800 plus applications that are services or connectors. And everything is for our self-service. So we can, as teams, create topics. As the upper screenshot, you can provide the name, the owners, what kind of a type contract it is, the retention policy that it has, how long does it stay on the queue. And when you have done that, you can see in the bottom part that that consumers and producers can basically interact with each other by connecting to that topic. You see one is producing, one is consuming, and you can see which schema is being used by the key values and the rotation period at the bottom. So that is how we use Axual. Then a little bit introduction into Spring for Apache Kafka. Spring for Apache Kafka. So Spring Kafka, that is a layer on top of Kafka that you can use in Spring. So basically you have Kafka as in the bottom, then you have the Apache Kafka client and Apache Kafka stream. And on top of that, you have the dependency, the Kafka, Spring Kafka, which contains annotations, for example, to enable Kafka to create a listener for you, or to enable retry topics. We will get into that soon. And also, there are some events and listeners that you can interact when something happens. And of course, there is a Kafka template so that you can produce Kafka messages to your Kafka. And for testing, there is also a library which contains the embedded Kafka broker, and the container utils if you want to do something with containers, of course. So that is in a nutshell. We will dive deep into it with code. So for me, I have now a local environment running Kafka in a container with the schema registration, the zookeeper, Kafka, and one broker. I use AKHQ for visualization. I will show you that as well. And I use varmux because I'm making an API call, because in big corporations we don't only have Kafka, but we also have some older stuff that still needs API calls. And then, of course, the service that is built in Spring Boot as a producer and a consumer. So what is basically the application that we're going to build? Well, I've built, but that is the document service. On the left, you see Kafka as a part of this diagram. Going back, what are we doing? We are consuming the topic from Kafka, the generate document information message from Kafka that does the document service. But before that, an order has to be generated by a customer. The order has to be filled in, and then also the customer relation information has to be put on Kafka so that our document service knows how to proceed later on. And that part is basically the CQRS microservices architecture, where we in our document service create a view in the database so that we don't have to call all the microservices. And of course, that's faster. And when everything is done, you can then give an update saying, document created, that is the status of my order, and that is the Saga pattern, basically, where you have maybe an orchestrator, the order service as your orchestrator of your flow. So I don't have much here because we're now going to do some coding. We have our listener and our producer here, and I can show you guys how that looks like. I have my consumer, which is just simple a Kafka listener annotation that will consume the message, that will call my service to create the document. Because we are insurances, I look at what kind of a product it is the car insurance or is it home insurance? I process something, and then I call the REST API to create basically that document. It gives me a document key back, so the response is a document key that I can put on the Kafka topic then again, so I'm producing a message to Kafka. Through here, I can do a successful message or an error message, but in this case, successful message, I'm sending it with the Kafka template, and I'm waiting basically on the response for 10 seconds, and I'm printing some information that I get back. So on which partition, what's the offset, and the time, how long it took for me for Kafka to process that message. So to do that, this is the message. I need to go to my GUI, and I can see that there are no topics because I haven't started it yet. So when I start it, it will connect to Kafka as my client and the group ID, and it will start listening, creating for me the topic that I need. So that's the document information topic, and I can place messages. I do it now in here, but you'll probably get it from another producer. So I need to select which schema it is, and of course something goes wrong here. That is too bad. Oh, I need to go here, sorry. That is too bad. I think I can even produce it like this. So I have to select a schema, but for now it's not allowing me. And as you can see, it is failing because it cannot process the message as it is not in the schema. Yeah, I'm not sure now. So it is weird. Looks like it. But that's one of the last slides for me. This is basically a poison pill. That cannot be deserialized. So it will just retry to consume it, but it will never get to consume it. So for that, I have to do something, and then we can continue. Let me say, it's too bad, but hopefully with this we can exactly demo gods. No, I know what it is, what I missed. So, just a second. Yeah, okay. So now we have implemented the service that is basically not working. But we can continue. It works in production, exactly. So the next thing is exception handling. If you can produce a correct message, consume the correct message, and then produce it, your happy flow is working. But what happens, for instance, if that endpoint that you're calling gives you 500 back? Well, it will handle it, Kafka. But how does it handle it? It handles it by the common error handler, and the default one is the common logging error handler. So it will try to process it 10 times, and then log it, and that's it. And basically, you lost your message. It got logged, but you cannot see what happened with it, why, etc. So there are some other things that you can use when situations like that happen. You can stop your container if something really bad happens and you really cannot continue. Then you can add that one, and it will basically stop your container, and normal processing of any message will happen. You can delegate the error, add a common logging, what I already talked about, and the mixed one when you have batch processing and normal processing. Then you can say, okay, this exception I process by the batch, and the other one by the normal process. There are some fatal ones that you cannot retry, you cannot do anything about it, the fatal ones. And the best thing what you can do is basically send your topic that you cannot process for after those 10 times, you cannot process it. Send it to your dead letter queue topic so that you can read what happened to it. You can see what kind of a message it was and act upon it later on if needed. So to do that, we can do that as well. And to configure that, you have the annotation. So you have your dead letter publish recoverer. You add, you say to what topic it needs to be sent to, and the partition from your call. So when you add this, it will go to that letter topic, and you can read what happened there. And probably because I already had one that could not be processed, I have a topic on here generated for me. Yeah, see, there is already in that letter topic for me with the message that could not be processed. As you can see, garbage. So that's how you can handle exceptions that happen for you. So let's go on. And like I said, there are those handlers are blocking handlers. So when you do retries with them, they will block from you from consuming other messages. And for that, there is not to do that, there is a retrieval topic annotation. What that will do is it will not block you from consuming other messages. It will create for you, or you will, if not possible, you will create retry topics. When something occurs, it will put that message to that retry topic, and with a backoff that you defined, I defined here backoff of 1,000 and the multiplier is 2 and the max delay is 3,000. So there is a backoff that increases by time. So for non-blocking retry, you need to create your topics. So to do that, you can create them, but the default naming of your topics is the topic name, and then added to it the retry of your delay. So you can see the naming convention there. It will be retry dash 1,000, retry dash 2,000, and then because it's maximum delay, it will be retry 3,000. And because the attempts are 5, it will put the 5th retry and 4th retry in the 3,000 retry, because there are no more topics created, so it will go to that topic. In the past, if you did not add an attribute that says don't recreate the max attempts topics as extra topics, it will create for every attempt that you have on the max delay, it will create the retry topic with 0, 1, 2, 3. So if you have like 100 attempts, well, you can imagine you will have like 90-ish topics created for you. And I don't think that you want that, so you can you can use this naming convention, and then you don't have to do that. So how does that work? Well, pretty easy, basically. You go to your consumer, you say, I want, on top of my listener, I want a retry topic, and this is basically it. And what you can do is say, I want to include the illegal state exception only as a catchable, and that will then, only that exception, if it is being caught, will create a message on the retry topic. But for now, we are not going to do that. And when I restart this application, and of course, the recover, I need to close this one because I have now 2 recovers. So when I do that and I produce, and I'm hoping now basically that I can produce a message. No, still not. But what will happen is basically it will try to process that message. It can't, and it will go to the first retry topic, which it is 1000, and then again it cannot process it. It will go to 2000, and here you would see then basically 2 messages, but because I cannot do it, you cannot see anything. And then at last, it will go to that letter topic because it couldn't process it at all. So these are being created for you, and as you can see, there is a dark side name in it because we don't want to have 1000, 2000, 3000 only naming. Then which team is basically responsible for that? So to doing that, you can use the topic prefix or the suffix and the suffix for your DLT topic as well. And that will create the naming convention as well for you. So that is one. And the other thing is looking at the blocking retries and the non-blocking retries. It will block your, the blockers will block your processing other messages. Your order is guaranteed because it blocks it, and the standard retries are 10. You can change that if you want, and the default is logging it. For the non-blocking retries, it will not block your queue, but your order of processing messages is not guaranteed anymore because you will put it on your retry topic. The other messages can be processed. So if the order is important for you, yeah, then you need to come up with another strategy still to have that ordering place. And yeah, it is basically the attempts that you put in there. So the attempts -1 because your first attempt is the one that you process, and then you have 4 retry attempts. And of course, it is sent to the retry topic for you, and then later on to that letter topic. So,
consumer is responsible for the retry.
Yeah. Not the producer. The consumer is responsible for his retry topics because he is putting the messages on the retry topic. and you can configure them together. So you can say, if I go here, you can say I have a blocking configuration and I have a non-blocking configuration. So for my blocking configuration, I want to retry on illegal state exceptions. And for my non-blocking, I need to exclude which exceptions I don't want to catch. So for here, the illegal state exception and the illegal argument exception. So what you see here is that the illegal state exception is being processed by the blocking one, but is not being processed by the non-blocking one. And the illegal argument exception is not being processed by the non-blocking, but also not being processed by the blocking one because you haven't configured that. So when you do this, you can then you're in control which exception go where for handling. And there is the poison pill, which was the first one. So the poison pill is basically a message that your consumer cannot process. That can be, for example, you're on the test environment and someone is testing his consumer and put some kind of a garbage message on there, and you haven't done anything to your configuration to catch it, yeah, and you come Monday to work, probably some other apartment will be on your ass because their disk is going to be full of your log messages that you consume, produce. So how to fix this? I already fixed it, but I can explain it. We go into our configuration. We create the bean, the default error handler, and then and that letter publish recover, for example, where you say when there are bytes that I don't understand, please put them into that letter topic for me to see what basically happened. Is it a mismatch in the contracts? Is it something that someone produced that is not correct? So you can reprocess it slowly. That is for the pill. We already consumed one and it went to the deadlet topic, so I will not go into that. And the next thing is annotations versus programmatically setting up your service. We saw some annotations that we used, but you can also do it programmatically. And why is it maybe better to do that or not? Is basically because annotations are, the pros are, it's simple, it reduces boilerplate, of course, and for a quick setup, it's handy. The cons are you're less flexible. There's annotation. You cannot on runtime you cannot change things as static configuration, and for testing and debugging as well, you cannot just easily change something, mock something out, etc. For the programmatically, then it is it's more flexible. You can add extra things. You can add listeners. You can easily manage states if you get an exception, that you then handle it differently. Explicit configuration, dynamic behavior on runtime. You can change things easily, and yeah, the cons are boilerplate and the complexity that you get with it, of course. And I have an example. So we had that consumer where we had the Kafka listener. It's pretty easy, right, to create one with an annotation. But how does that look like when you're doing it on your own? So you get some beans. So you need to set up first your container factory that needs a consumer factory that needs your configuration. So you can provide them by properties, or you can provide them in code as well, what you want. Then the container, so on which topics am I listening on, and at last your listener. If you have done this, and I can add the configuration back in, I start it up, this will yeah, I cannot send a message, that's too bad, but it will this one will also pick up the message coming in and just print the value. Too bad I cannot send any messages. I don't know why it doesn't give me the correct schemas. That's too bad. So yeah, and the next thing is you want to test it. You don't want to go on the test environment and hope that you have configured everything correctly and it works out of the box, right? So you can do that on 3 different flavors. You can use embedded Kafka that comes with the test dependency. You can use containers where you run Kafka and you test against it. And for the streams, you can use the topology test driver. I'm not going into streams, so for now we will look at the embedded Kafka, how you can set it up and use it. But the most important part is don't overuse it. Don't do that, because these tests are heavy to use. So when you have your test, and we want to set the embedded Kafka broker, we define the annotation. We say which topics do I have. Then you provide your broker. You set it up. Set up your broker. You set up your properties, your Kafka template. And because we are using schema registry, we set up our schemas as well. So when it is called, we are mocking them out via the schema calls in virmock. So we set up which schemas we have. So we have a key for it and a value. Again, here a key and a value. And then when that is being called, we give basically the correct schema back. And when everything is set up, so you set up your where is it? You set up your listener. Your listener is down here. Yeah. Yeah, your listener, sorry. You set up your listener, and then when something is put on the on Kafka, you can read that message out and put it in your queue, so that your blocking queue, so that you can then test it. What you have basically got from putting something on Kafka. So when you run this, we are producing that document information message, and at the end, we will get the document key, which is then successfully, so the document key is in here. When we run this, hopefully this will succeed. And you will see that it gets processed. Not even this is working anymore, so funny. Yeah. So this is not even working, but this is, yeah, the demo gods, of course. So this is for testing how you can do it. And to wrap it up, basically, the lessons that we learned as well. For monitoring, monitor please what you get in. Monitor your Kafka cluster as well. We use micrometer to do that. Enable also your tracing so that you can see from which topic to topic the message went to, and you can trace your messages basically. Use AVRO schemas everywhere. Now they're giving some trouble, but watch out also for breaking changes. So inform the team if you're going to introduce breaking changes. Maybe you'll even introduce a new topic because if it's a breaking change. And yeah, Spring Kafka makes your life easier. You can use those annotations as well, but you still need to understand how Kafka works to use it and to deep dive into the communication. So that was it.